seen was that whenever you have two lines, if one transversal happens to be perpendicular to both of those lines, that means that those two lines have to be parallel. That was one of the rules to show that lines were parallel. So that means that these two have to be like this. Okay. Now, I remember yesterday in the discussion, you guys were like, well, there's no angle pair relationship between the 5 and the 7. I think that's what we're talking about. I get the two of you so confused. I know. It's uncanny. I feel sorry for you. Look at them. Anyway, remember the trick that we did when we first talked about parallel lines? If you pick an angle, walk it through. Every one of those angles that share a tick mark would be true. Every one of those angles that does not share a tick mark also true. But in essence, if it has a tick mark and it doesn't have a tick mark, it makes them very good. So those two with the value of A would have to be supplementary, which means they have to add equal how much? Very good. So I have 5A minus 43, 7A minus 17 is 180. So let's see, we get 12A. Is it minus 60, I believe? And now you're back to a quick step. In order to solve this one out, you add 60 and then divide by 12. We have A 240. You should get 20. That's a nice little trick on that. How do you set that one up? There's one of those that aren't told that the lines are parallel. You have to show that they are parallel. Let's see. The B value one, that one's a little bit easier. Let's work because what's the angle pair relationship between those two? Yeah, alternate exterior. So they have to be congruent. Again, if you just follow the tick mark, you get 8. B is 11. B is 30. Moving a bunch of jump around here, you get 30. B, you get 10. And obviously, there's a cool thing about that. You could set the negative values, but try to stay away from such a high. Negative. Oh, I'm sorry. I was thinking 5 times 4. Sorry. Yeah, you get, what is that, 100, you get 57, and then not drawn to scale. Yeah, I see where you're getting with that. Yeah. And that's kind of the downfall sometimes when you have pre-made ones. It's just the idea of not to scale. Yeah. What's that? No, somebody wrote that. Just they're not using good spacing like we learned in kindergarten by putting your finger. It's funny because I never remembered that, but our youngest son right now is in kindergarten. He's learning to write the sentences and all. When he's writing out words, he takes his finger and he goes to the next letter. And his handwriting is much nicer than mine. Chapter 4. Chapter 4 was the nightmare chapter of proof stuff. But as you recall, what we've talked about with how the proofs can look in terms of final, and we'll talk about that here in a second. But the final is really simple, as you probably noticed already by looking at it. Back. But one of the things that we talked about here is, can you go through and identify the ideas of how to try to. What what does it mean to have S? What does it stand for? Side, 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 angle, side, angle side. What's the HL? And what is that only for? Right triangles, very good. It's just a matter of going through the rest of it. Obviously, we all know that there's no the rest of it, as far as solving and working with variables and stuff, was relatively simple. So on this first one here, that one dealt with what we call was the angle on the outside. And what we did was, I don't remember this, this angle is always equal to the sum of the two it doesn't touch. And I think we actually had a problem like that in the last chapter. I'm sure we did. Every once in a while, that one shows up irregularly. So the reason that happens is because this exterior angle is supplementary to this one. When you supplement, you have to add a 180. Well, that also means that the other three angles also have to be 180. You can do a bunch of substitutions, but that's there. So what we do is that we know that 6x minus 7 has to equal 103 minus x plus 2x. And now it's better dividing by terms of the 1. So you have negative x and 2x is. What was your? You have 6x minus 7 is 103x. Excuse me. Now you have variables on both sides. Constant on both sides. What are we going to do? Add 7, subtract x. Divide that out. Once again, the second part of that review thing goes through. How would you be able to show whether or not these things? And this is when we would just mark our diagrams. Things like that. So as you look at this one, what is it missing on the missing vertical angles? So it's missing the vertical angles in the middle here, which gives us now angle, angle, side. Vaguely remember that? Next one, what's it missing? Reflexive property. Reflexive property in the middle gives you then what? Excellent. Number 4, what's it missing? Gee, is this like a broken record? Remember the trick we talk about vertical angles a lot of times? We usually talk about in terms of, if you see a diagram that looks like a bow tie-ish, that's usually a so this gives us now angle, side angle. What do you get? What do you have to mark on 5? Another reflexive property. Now, what is this? Yeah, that one's an example of hypotenuse leg. Reason that hypotenuse leg is because you got right angle, and a crossing right angle is always the. What about 6? Ah. Whoa. Ooh. Is there any of this in math? Yeah. No, you can do that. Okay, there's nothing you can do on that. About 7, though. This inverted triangles gives you. And then last but not least, you have flexes, which gives you side sides. Being able to identify from the diagrams too. Finding values of x and y. This goes back to properties of the triangles. Let's talk about isosceles lateral. When you have an isosceles triangle, or excuse me, we'll talk about this one first. When you have an equilateral, if you have an equilateral triangle, that means all of your angles, they all have to equal 60. So when you have an equilateral triangle, that gives you have then what's called equiangular. So that means all of them have 60. All three angles are the same. They all have to equal 180. They're all 60. So algebraically, you have two problems. X plus 20 is 60, and 4y is 60. Subtract 20, what do you get? Divide by 4, what do you get? You have to do a little bit more work. In 10, you have to do a little bit more work. The reason you have to do more work is it's not equilateral. In this case, it's isosceles. When you have an isosceles triangle, remember, your isosceles triangles always have legs. The legs look at the angles, the base angles that are, and it goes vice versa. If you've got base angles, then so, in the triangle on the bottom, really the only where we start. When we start with that, we've got the angle on the left hand, the right hand. Also. Now, if I had 59 and 59, subtract that out of 180, what am I left with for x? 60. So if this guy's 60 means point above it, it's 50. Which makes the other two angles. Well, wait a second. Is that possible to have angles that are the same triangles? Okay, because remember this angle. But in this case, about this. When you have two triangles, sides that scale model. You have an isosceles left, which gives y at much? 65. 65 and 65 is what? 130. Subtract that from 180, you're left with 12. You are given that you have all three angles congruent, which means all three sides are congruent. So therefore, if one side is 24, they all have to equal 24. So you wind up with some very fast math. 2x has to equal 24. 3y has to equal 24. So you get. And you guys are all going, why wasn't chapter 4 this easy the first time around? Now, before we get to the next part here, I want you guys to flip to the very back. And I want to show you guys what it means all this, because chapter 4 is when we talked a lot about this. After chapter 4, we didn't worry about it. Now, what we did was we recreated, or I should recreate. We gave examples here of how we're proofs. when we take care of the final itself, and look at how the quiz, instead of making multiple choice throughout the entire thing, we thought it'd be easier, a little bit for students to work. I just had to use a particular way. So on your back page, each one of those has two different reasons. Means they don't correlate. So when you're going through this, what I want you to be able to do is identify. So, for example, obviously we always start with 3 times 3. So the next step was 3 times 3. What did they do? Very good. So which one of these says something about distributing B? So there's, see what I'm getting at? Can you identify what they just did from the reason? They go from 3x plus 3 plus 24 to 3x equals 21. Yes, they call it 5. No. What happened? We subtracted 3, right? So that would be A. And then what happened now? So again, guys, remember yesterday I told you that the proof portion 7 questions. 7 questions out of 45 will probably be the 7 easiest questions on the time. It's 15% of your grade. Yes, ma'am. No, the tests are. Yeah, absolutely. All of our finals all the time. And it asks. So, yes, obviously, because at times, and all the whole thing, 105,000. So, I'm going to ask that. So yeah, by all means, finals you can write all over it. It's not a big deal. There's plenty of space. Same deal here, and I think this is kind of what you're getting at when we want to mark our diagrams. And this is huge. Remember, how many times did I tell you guys, mark your diagrams, mark your diagrams, mark your diagrams? This is why. So if A is congruent to C, I'm going to go to my diagram and go, C. X is the midpoint of AC. All right, so there's this and this. And then I need to prove that BX equals DX. Okay, well, we're getting there. Now, without even going any further into the proof itself, what's one thing I know for certain I can mark on my diagram? The vertical angle is very good. I know that's one of the things that we can do from diagrams is that I can always mark vertical angles. Now, from there, there's really, I know now that the triangles have to be congruent. By just looking at what I have marked right now, how are those two triangles going to be congruent? Without reading anything. It's going to have to be an angle side angle problem. Okay. Now, I've just taken, I don't know, a minute to just work with the diagram. Now I'm going to go through it and read the questions. So, going through here, it tells me my given. A is congruent to C, X is the midpoint. Perfect, done. I have a midpoint of, oh, but they didn't use that yet. They went right to AXB, CXD. Well, AXB, CXD, that happened to be marked up because of what? Vertical angles, very good. Those have to be vertical angles because that's what my diagram says that they are. Why is AX congruent to CX? That fits in the midpoint because it's a midpoint. Why do I have triangles congruent? Well, I already marked it down and wrote it down why they became congruent. And why are extra parts equal to extra parts? Ladies and gentlemen, that should be a question. That should be honestly is really sure. I really that's what makes it fun. because it's right in front, and it's not trying to do it all. Not like you can work. Yeah, exactly. All right. Questions regarding how the proofs? Yeah. All right. Back then to chapter, where are we at? 5? All right. Chapter our segments triangle, where we had mid segments, means, distance, altitudes, things like that. Now, again, take 10 minutes as you're going through and preparing for the test. Read your vocabulary. You don't remember the vocabulary, go back up to the computer and pick it up. When we get done with this chapter, I'll show you guys stuff on the textbook stuff on the Chromebook also. So let's see here. First couple of problems, we've got to solve for x. Well, let's see. In the first example, that segment has connected to the triangle. If segments connect the midpoints to the side of a triangle, that means it's a mid-segment. The mid-segment is always parallel to the side of the triangle, and it's always equal to how much of the side. So that means that x is going to equal half of 27. So depending upon how the answer is written out in terms of multiple choice, or if it's written out to solve for x as the show your work problem. Show your work problem, you can leave it as all 27. Or if you press buttons in the calculator, you might say, what that's 13 for 5. It just depends on what you're doing. Not too bad. Same deal here. When I'm looking at that, if I know that I have the perimeter of triangle A is 96. This is a bit of a trick. If the perimeter of ABC is 96, yeah. And the reason it's got to be half is because each of that triangle on the inside has half the other one. Each segment, this is 3 segments, this is just a single of it, and so on and so on. So what's half of 96? 48. So you add them all up, 4x, and 1, and 2x, 3x, 2. Let's see, 4, 2, and 3 is 9. What was it? So I know how to write. You give me the answer right away. I'm like trying to write a 5. I'm writing, say, right 3s are saying 5. It's going to be half. The reason that's going to be half of it, remember, if the whole side, when we get to that triangle part, that if this part, for a real easy way, if this is, whole thing is 2, that makes each one of these 1, makes this 1. So that interior triangle is going to be half. AD is an altitude, and find the value of x and b is median. Okay? That means you kind of have to remember what some of these terms mean. So real quick, you had a couple of terms in this case. We had altitudes, median. Now the altitude was from vertex to the side, and it was perpendicular to the side. Real easy way to think about an altitude. You know how your folks will tell you to stand up straight instead of slouching? If you stand up straight, you're as tall as you can be. So it's always going to be from vertex side opposite. That's perpendicular. Whereas median is going to be from vertex to a mid. It's a quick reminder. So back to the problem there. If you have an altitude, if AD is an altitude, what happens at that 90 degrees? Good. So I know that this has to be right A. So in order to solve for x, say equal to. Now, all right. Let's say you had a diagram of that, and you couldn't kind of just figure it. As much as I stuff, and you kind of do that. I mean, every once in a while, it's worse towards you're talking about a film. If you don't know how to map, it looks like it's 90. Try it. See what happens. Yeah. Kind of the thing here. Mr. Fontana and I were talking about this earlier today. So, you know, as much as geometry is kind of interesting throughout the day and whatnot, if you're not careful with some of it, you can make a dumb mistake. But usually those dumb mistakes happen because you didn't know what something meant. You know, oh, it's 180 degrees now. So, just, you can kind of get away with it. Same thing with the next one. If I'm trying to solve for x with the other parts, if I'm looking at that, I don't know what in the world a median is, but if I look at those two segments, they look kind of like they should be the same. So you set them to each other. Subtract 2x, add 25, and lo and behold, it appears as though we mathed correctly because we got 15 for both of them. Yeah. We should have. Super exciting fun. Oh no, I don't know what I'm doing. What should I do if I don't have a picture? Right? Right. Is that just IT? Is it a, or is it a cloud?
That's cloud I
That's straight out of the or maybe both of them. I was on the Bozo show. Yeah. Oh, those were my first. You laughed. I was in commercials. I was. I was in a digital art. So if you want to figure out which angles will be the greatest, smallest, largest, first thing you do is draw the triangle, and then label your sides. Let's see, AB is 3, BC is 4, C is 5. Now, what was the rule regarding 5 degrees? Remember? What was it, Josh? Very good. Yeah. Remember the rule is that the smaller the size, the smaller the cost. Is the larger size. So if I'm looking at something smallest, largest, which one has the smallest size? It's 3, so that means C is the smallest. So we go at angle C, then would be angle A. And then by process of elimination, it leaves me with this is a very simple problem. You just have to be careful. Sometimes they'll say listed from smallest to largest. Same deal here. We have A, B, and C, 20, 12, and 10. B, A, and C then. That one. Angle C in this case are cross. B would be small. And to go along with angles, then, or excuse me, sides, then we go angles show up sides. We'll just say angle. Yeah. So let's see, triangle. Let's see, which side with it? C. Bless you. Hey, I wonder what this HH stands for. Smallest to largest, the smallest of this next one is AC, the next one is, last but not least, next one just shows you a couple of ways of setting up and solving directs. In number nine, you are a point on an angle bisector. When you're a point on the angle bisector, it's your equidistant sides of the angle, you are perpendicular to the sides, which therefore means that 7x plus 3 has to equal 10x plus 9. No, it's x. No. Uh, 10, you are on a perpendicular bisector. When you're on a perpendicular bisector, you are equidistant to the endpoints of the side of the bisector, which therefore again means that these two are. So let's see, 9 x, 4.5, or 9 halves, 4.5, however you want to write it out, or however they give you information. Remember, perpendicular bisectors always create isosceles triangles. Perpendicular bisector always creates isosceles. Centroid. Centroids were the weird one. The point at which everything met, when you had a centroid, it was from vertex to midpoint, vertex to midpoint. So all these were bisectors. And what happened was that you had vertex to centroid, and then centroid to side. So we wrote it out in terms of the generic algebraic statement. From vertex to centroid was 2/3 the whole. From centroid to side was 1/3 the whole. Or the other thing we did double the centroid, the side, it equals the vertex centroid. And I think after we did a few of these types of problems, you guys just kind of. So when you're looking at this first one, you have MO and MP. So MO is the vertex centroid, and MP is the whole thing. Is that plus 24? Is it minus? So if I'm looking at that, I have vertex centroid, and I have the whole thing. So of those three situations, the top. So I would say that the vertex centroid x plus 4 equals 2/3 the whole thing. And do you guys remember how to use the fraction bar in your calculator? Yeah. So when you're using your fraction bar on the calculator, you would have to multiply that 2/3 to both the 9 and the 24. So on your calculator, you guys would just make a fraction bar. Wow. Make your fraction bar like you guys did it. Your n over d button. 2/3 times 9, hit enter. Do the same thing. And change it to 24. Okay. The right hand side is a 6 in it. So x plus 4 is 6x minus 16. I'm crazy. Add 16, subtract the x. And you get now, what's nice about one like this, that if you just remember the whole 2/3 and it holds and having all that math, you just know that much. You know just that much. You have values in the multiple choice situation. But you just substitute values to see which one is going to work for your sake. It's not that difficult to work backwards out of it. Same thing with the next one. Next one is just dealing with the whole thing. That was 2x minus 3. That was close. So now you've got the vertex, the centroid to side. And one part of the use of that was that we said double centroid to side, it has to equal vertex to centroid. And I think this might have been, out of all the stuff, in terms of all the weirdness that we had off the let's see, we get 4x minus 14, 3x, subtract it, add it, get x is. I know. Open your Chromebook. I want to see if something showed up for you guys as far as the. No. Yeah. And I want to see if it can. I've never done this yet, guys. If you don't have your Chromebook, you know, I ask you books to test. I did say that, yeah. Make sure you are paying attention because you need to know this. Give me 1 second, I gotta pull this up, and I gotta have to try to pass it on too. So, and everything here. So, if we pull up the textbook here, I want to see you show. If you pull up your textbook stuff, did it show you guys the sign? Go back. Yeah, go back. Say anything about. All right. right in the middle, see how it says there is a due date in the next second? Right in the middle, before you would click on the portion that says next one, there's, and then which parts I know it's different on my screen versus yours. If you look at it, it says there's a book on the left and it's orange thing on the right, blue stuff. And then the middle one is something what happens. Wow. Hey, boy. Yeah. What's Sean? You hey, on that. Guess what it does? Because he's those are reviews. They're automatic. Okay. So it's that those and that there are just questions. So if you click on one, click on that top. When you click on one of them, well, now click on it where it says work to complete. Hit start. Now, as you go through this, it's going to give you a bunch of questions. Obviously, some of them are going to be topics of things that we've done. There might be a couple here and there that aren't, but those themselves are great extra questions. And what I like is that you go through them, you go through feedback whether or not you got something correct. And if not, if you got something wrong, we'll be able to tell you what page to go back. All right, so go through that over this weekend. Go through those questions that are self-generated on that computer, and that'll help you be ready for Tuesday. So use those to create audit. Okay. We so go through those things for Tuesday. And then I will have a couple extra things for us to look at, and then any other last minute questions and stuff, things. Okay? Good times. Super exciting. Something. Okay? Yeah, it doesn't allow me to not set up question thing, so that's how we try it.